We're about ready to go into 6.1a, and so hopefully we're ready to go. Just want to give you a heads up there, and here's the podcast on that. Into B as well. Cool. Alrighty. Hey, as we get started, I think we're up to that point at least right now. Here's what we're gonna do. I'm gonna give some tickets out, but I really want you to think through why these things exist. Okay. So as we answer the questions, we'll hand out tickets. All right, up here, stay up here with me. We'll hand out tickets for specific answers that correspond. Okay. So again, and then we'll put a little bit of an idea of like, okay, so what is the takeaway from this 6.1 day one? Okay. All right. So we've got the probability model there, which is good. Someone raise their hand. Number 2. What makes up this probability model that makes it valid? Jaden, did you have your hand up?
Oh, yeah. I was just going to say that yes, it is, because they all add up to 1.
Yeah, so all of them have to add up to 1. That's perfect. That's number 1. Okay, so we put that there. Add up to 1. All right, someone raise their hand and help me. What would be the second thing that we would have here that makes up a valid probability model? Oh, let's go 6 tickets right here. 6 tickets. Lindsay?
Each probability between 0 and 1.
Nice. Each probability falls between 0 and 1. You want to say that too, okay? So each probability is between 0 and 1. Nice. All right, here we go. Question. Is 5.7167 a possible value for x? Bronwyn, what do you think? Yes, you can't have point. Yeah, well, wow, Jaden.
But you...
Yes, you can't cut up children. Very good. You can't cut up children. That's very gruesome, isn't it? I'm sorry. You can't have part of a child, right? You can't have part of a child. So this would not be able to exist, okay? Not be able to exist. We'll come back to why that's the case and how that impacts chapter 6 here, okay? All right, number 3. Chloe and I think it was Chloe, we were talking about histograms and how this one is just a little bit different. Can someone tell me why this histogram would be different than the ones we maybe have talked about in the past and why? Yeah, Alex, go ahead.
Is it because the y values are percent chance?
Okay, yeah, this is percent. Very good. I did mine out of over 15. Okay, so whatever it was, so 1 over 15, 2 over 15, just to make it easier here. So that could be part of it. Does anyone else know why else that would be different? John Michael?
It's not a range, it's just 1.
Yeah, because there's no range. Because of the fact that you can't have 5.7167, we only have a specific value. All right, only a specific value. Now, question, is this categorical, raise your hand and help me, or quantitative? And how does that impact the type of graph that I have? Brianna?
It would be quantitative.
Great job. Good. And so why is this, so why do we have no gaps when we do this? So like for number 1, I did 3 of 15. Number 2 would be 7 out of 15 over top of 2, right? And so on and so forth. Why do I have no gaps in this? And not a what?
And not a bar graph.
Why would it not be a bar graph?
Because bar graphs would be categories.
Man, that was awesome. Nicely done. That was really good. Okay. Yeah, and that's why it would be the case. So if you've got a histogram right now, hopefully it matches up to this one to where there should be no gaps here. What do I do at 4? Nothing, right? Just like that. What about 5? We just go to 1. And then 6, we go to 1 as well, okay? All right, sweet. All right, shape-wise. What type of shape do we have here? We'll include this on this side. What type of shape do we have in this histogram? Lindsay, what do you think? Yeah, we're going to say skewed right. Nice. And put an LY word in there, someone.
Approximately.
Slightly, yeah. It's not approximately normal, maybe. I would say it's slightly skewed right, okay? So if I was to describe the shape, slightly skewed to the right.
Oh.
Was it now? Kick now? Alright, here we go. Next one, here we go. Question number 4. Here we go. Probability. It's not going away. We're just using it differently. Probability that the x value would be greater than or equal to 3. Someone describe that to me in words, and then we can solve it here in a second. Catherine?
That means the probability of having 3 or more siblings.
In your family, yeah, I like that. So if I were to describe this in context, this is the probability, and this is important, this is context for us, probability that a randomly chosen family, will have what? 3 or more children. Good, Shane and Alex. Good. 3 or more children. I'm assuming that was Alex behind me. Is that right?
Yes.
Awesome. Okay, so once I do this, Alex, what would I do to solve for this?
Well, you add up all your values in the 3 category or higher.
Yeah, 3 or higher, right? So if I were to describe this again, I would say probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of Jaden 6 or more, right? Okay, I'm sorry, Jacqueline 6 or more. I'm sorry. I forgot Jacqueline was the one. Jaden's like, I didn't have 6 or more. Wait. All right, so what's the probability of having 3?
3.
Jaden.
2 out of. I mean, wait. Sorry. Yeah, 2 out of 15.
Yeah, okay, so we got 2 out of 15. Again, I put in context. 2 out of 15 plus what?
3 out of 15.
3 out of 15 plus what?
No, for sure.
3 was 3 out of 15. Greater than
No,
or
wait.
equal to.
Oh, this is 3 out of 15. My bad.
Wait, are we not on number 5? I'm so sorry.
No, we're still on 4. I'm just showing the work. So
Oh.
this is 3 of 15 plus 0 of 15 plus 1 of 15 plus Jacqueline's 1 of 15 over here on that side. Cool? All right? So we add it all together, and what would be that probability of that individual having 3 or more? 5 out of 15 or 1/3. Nicely done. Cool. Cool. Questions on that?
You gotta go full into the dot. There you go.
Oh.
Is that right? It's creative. All right. Next one, number 5. Describe it in words. I'm not going to write all of this because we just did the same thing. What is the difference between number 5 and number 4? Someone raise their hand and help me with that. Michael.
Number 5 is just greater than, so you're not including the 3.
Bingo. Not including the 3. And so because of that, if it's just greater than 3 children in the family, then we would say that the probability would be excluding this one for number 5, which would then give me what? 2 out of 15. Nice. So we'll put that there. 2 out of 15, that's there. Okay? On an AP exam, you got to show context, and you've got to show that right-hand side as well. Okay, now, 6 and 7 are the key, kind of the takeaways of today, other than one other kind of minor thing towards the end. The average of the x values. Okay? Now, as we backtrack, what would be the average of the x values? Just the x's. How would we find that? Brianna.
You would add the probabilities up and then divide it by 6.
I like this thought. Now, I like where you're headed because you and I think it was Jacqueline and Shane, we were talking a little bit in regards to there's an issue here. We can't just average 1 plus 2 plus 3 plus 4 plus 5 plus 6 and divide by 6, right?
No, you would add your like you would add 3 plus 7 plus 3 plus 1 plus, right?
Yeah, no, I agree 100%. But what I want to do is just back up and show why this is an issue. Cool? So if we did just average the x values, that's all they want me to do is we would just add these up and then divide by what? 6, right? And when I did that, did anyone do that?
We got 3.5.
3.5? Okay, that's good. So this is 3.5 right here. Now, Brianna said it, and then I had a bunch of people we were talking said this. Why is that an issue? Someone raise their hand and just help me. What's an issue with this number 3.5 as our average here, Sarah?
Well, our graph is like skewed, so the outliers like 6 are just like unusual occurrences.
Yeah.
Will not tell the full story, and it doesn't really convey what like something like the median would.
100%, yeah. Does this have the same value as something that with 2? No, right? So we have to bring the probability in somehow Brianna, you were onto it. I thought you were onto it right there. So this does not tell me you were really close to it. Does this value tell us the average? It doesn't, right? Because we didn't bring in the what? You said it, the probability, right? Now, I think you're on the right track. Could you explain to me again, how would I find the expected value, is what we call it, or the mean of this probability model? You're good. So real quick, this is expected value. So you want to get that down. It's a good keyword. Same as the average number. And we know that it's a no, but how would I find the actual value in and of itself? So here we go. This is how we would do it. We would take each of the numbers, 1, 2, 3, 4, 5, and 6, but each of them would have to be multiplied by its current probability, right? You kind of were saying that. 3 of 15. 2 would be 7 of 15.
Is that number 7? Or that's number 6?
This would be number 7. So number 6, we're showing why is that an issue? Because we're not bringing in the probability. Each value takes on a different, holds different weight, right? So we take each of the values of the x and multiply them by its probability and add them together. Okay, so we've got it here. 3 was 3 of 15. Cool. 5 is 1 of 15. Cool. And 6 is 1 of 15. Cool. All right, someone, real quick, just kind of throw that in the calculator real fast there. As we're showing some work, so we got 3 of 15.
Wait, so the answer is no.
It would be no, yes. So does this value tell us it would be no while we're writing this? And I'll put down the official answer. So it'd be no. 2 holds a larger impact than 4. Cool. Chris, did you give me that number? 2.47? Okay, so when I do all of this, right, and I add them up, 2.47 is the average amount that we would expect over the course of a lot of people that we randomly selected, okay? So this would be the expected value.
Yeah.
Expected value for many random students selected. And I put a little context more into it on an FRQ, talking about children in your family, right? Okay? If you're good, say uh-huh. If you're not good, talk to me. Does that make sense? Catherine, go ahead.
Could you say that again? With expected what?
It's the expected value for many, many random students that were selected. Does that make sense? So if I averaged out, if I selected you at random, right, and I randomly selected y'all, if I did that over the course of like law of large numbers, I would expect that average would approach 2.47 children within a given family. Does that make sense? Perfect. All right, are we good? We're about ready to get a breather real quick. Golden nugget. But before I do that, when I go back here, this idea of only being able to select like a set number with no gaps in the middle is this idea, the difference of discrete, you want to get this word down, versus continuous, okay? So discrete is something like Coach Jay's height, right? That's really rude. Saw that, Jaden. When I look at this, right, is there a break between someone's height? No, right? Think about it. You could be 4 foot 3.38, right? I don't know. That's random, right? You could be 6 foot 3 1/4, right? There's no break in the action. Whereas with this, are there breaks between 1 through 6?
Yeah.
Yeah.
Yes, because this is the case, we call this discrete. So discrete means that there's breaks in the action. Someone give me an example of a discrete variable. Right, go ahead.
So it's discrete because you can't have like half a second kind of thing.
Correct.
Okay.
Exactly. Like you can't have 5.716, right? It's exactly right. Do you have an example of a discrete variable?
Anytime you're referring to people. I don't know.
That's actually a good idea. Can you think of like an instance? It's a little weird. It's a little funky. Sarah, do you know?
If you're playing with cards and you're like, I have 3
so the probability of selecting given cards, right? How many red cards do you have and that sort of thing? That's good. John Michael?
If you're counting like what roll you got on the die, you can get 1.5 from the die.
Yeah, that's good. So the amount of times I rolled a 6, right? Versus a 5 and so on and so forth. Jaden and then Catherine, I got you.
If you were counting on average, like how many dogs came to a dog park, like throughout a month or something, you can have like half a dog.
Yeah, so what's the probability I go on a certain day and the probability of having an X number amount of dogs? Good. Catherine?
AP school.
Oh, yeah, so it's a 0, 1, 2, 3. Can you get a 0?
Yeah, you get a zero.
You don't put your own
Oh, there you go. You put your name on it, I think you get 1 or something. It's good. Anyway, all right, so that's what we're focused in on. Golden nugget, and then we'll take a breather here. Here's the golden nugget. We'll write this down. You pretty much already have this, but just as like to formalize what we just talked about. Discrete, fixed set of numbers with no gaps. Continuous can take on any value. By the way, when we look at continuous, if you're wondering like what is continuous, we've been doing it, you just haven't really noticed it. A continuous graph would be like a normal distribution, right? Does that make sense there?
Wait.
So like continuous would be the grade on our last test, right? If I just took like the raw score, right, without rounding, that would be continuous because it could be any specific grade from 0 to 100, right? Within that. But if I said, or let's keep going. If I ran the mile, right, the mile would be continuous because it doesn't have gaps in between the specific numbers. Does that make sense? Because I could technically, you don't get it?
Wait, so this continuous means like that it can be like any value,
Mm-hmm.
literally any value.
Any value. Whereas discrete means I've got to either have 1, 2, 3, 4, 5, or 6, right? So you can't have 1.3, 1.4, right? That would be discrete. Whereas continuous could be any number from here to here,
So
right?
it doesn't matter like the pattern of if it's going up or down. It just
Yeah, it could be skewed right or left. That's okay still. But it means that there's no, it's not set, right? Does that make sense? So like discrete, it has like gaps, it has no gaps between the numbers or fixed set numbers with
It's like the same amount
actually
between
discrete.
each number.
Correct. That's exactly right. So in this, and I messed this up, this should be with gaps. Cool? Does that make sense? So with discrete, it has gaps, just like Shane said. It's like set in place, like 1, 2, 3, 4, 5, and 6 has the same gap between each of those numbers. Does that make sense there? Cool. We're going to do something where I think that will help here in just a bit. The last thing, make sure on the histogram, we know that we relay what's over here on this right side. Okay, make sure of that. And then over here down below, can anyone kind of interpret why this is the expected value formula? Because this is what you'll get on the exam. Why is this the expected value formula?
Yeah, that one.
This is a little funky. Sarah?
It's like the sum of, so the X is like, is that like how many you have, like siblings, and then the P is the probability of what's happening?
Yes.
So you multiply each and every one of those values, and then you just add the sum of every one of those.
Yeah, what's this right here? Other than a great tattoo, what is that?
That's the add multiplier.
It's all the sum, right? So I would multiply the value times its probability, add them all up together, and that's my mu, or what I call my expected value. Follow that? Looks funky, but that's what we're looking for. Okay? All right, to kind of help out, let's play for Coach Jay's leftover Halloween candy. Okay? Yeah, we're gonna play for it. All right.
Wait, I think we all need
Yeah. Do we need to? Do we need a quick bathroom break, real quick?
Yeah.
All right. Do this. 2 minutes. Go. You're good. We'll do this right after. 2 minutes.
Wait, so
Sí, comprendo.
oh that was
Yeah.
do we do this for 2 minutes?
Oh yes. Okay. So if you want to do, so I'll give you an option. If you do the multiple choice, you get half back, and if you do the FRQs, you get a quarter of the points back.
On that part.
Yes.
Okay.
However, what I would say is you have to choose one or the other. You can't do both. So whatever one you think
I
would
don't
be.
know what's more beneficial.
Mine are gonna be worth like 5 cents.
What if you did it like a course? That's more beneficial.
It actually you don't. Just barely, but yes.
Did you see the scene at the Thomas press conference?
Yes, wait.
And the poor girl,
So
the
you
intern,
get that
tried to
stuff
grab
today?
the mic to stop.
Right.
Her work until like sophomore.
I just
So she walks up
yeah,
to him and he's holding the mic, right? And she's like,
Why was
it gets
this
heated, and she
1:40?
walks up, she goes, and he won't give it to her. And like, it's a CNN guy, and he's been the way. It's like, don't you sit. And then she was like,
correct. So
Yeah,
you
like,
0.11
wow.
times 0.11 times 0.11, right?
it's really
Okay,
sad
keep
though.
going.
I thought you
do that.
was
You
1.11.
show this kid, I was like,
No, to
You
the
do point-
fifth.
Oh, no.
To the fifth.
Oh, okay.
And then 1 minus that is actually because this is
so
that you will win at least 1 prize. The fact that you would win no prizes would be 0.89. Does that make sense? So if you wouldn't win, would be here. So it'd be 1 minus 0.89 to the fifth. That'd be it. And then once you do that, you should be good to attack it. Attack it on that one.
I think one time in freshman year, I had in my
Cool.
Wait, Coach Jay. For this one, why was it speed out? I thought it was. I thought they weren't independent or mutually.
They are, you're right, they're mutually exclusive, but I'd have to show you the actual, why they are, why they are. It's like a formula that I could show you. If you want to, we can meet in that break time and walk through that. But because it takes a little bit more explaining on that one. But the mutual exclusive, you know, because this number's not 0, right? There is an intersection. So because of that, that's why that would not be mutually exclusive. Cool?
wait, how many points back will you get for all the choice?
2 to 2.5.
Okay, we'll go through it.
That's
Okay, so I got 85 potential of mine. Or 89.
Yeah, for sure.
Do I do free response?
So, like,
as well, or
they
just
all
one or
the-
the other?
One or the other. If it's free response, I usually give back about 1/4 of the points.
We'll go with that.
So I'm thinking multiple choice. I only do 1/4 because usually you show work more in an FRQ. So that's usually why they're. All right, you ready to play for my candy? We're waiting on Lindsay and Jaden a little bit. Actually, before you do this, here's what I need you to do. I need you for this next part of the lesson we'll get to in a second. I need you to find the amount of money that you're going to make post-college per hour. Okay? For what we're going to do. So you're just going to choose at random up here, and you're going to hold on to this and give it back to me at the end. Sound good? So, yeah, this is per hour, your wages after college. Okay? No pressure.
Like right out of college?
Right out of college. You're going to hold on to this here in a second. So if you want to come up here while we're waiting on some people to come in, so just get one of these.
Oh, good thing you did it. We got $1.
Chloe's $1 an hour. Hey, there's still tips though. You can still get tips.
That's how much you're gonna make after college.
Yes.
How much did you get?
Congratulations. Congratulations.
What if we chill?
That's a 7.
Lindsay, did
You
you
got 7.
chill over
You
here?
got 7.
Okay, I know I didn't just leave. But it's different for me.
It's really soft.
Okay. That was really close. That was really weird. That was really too close. Okay. Jaden, are you okay?
Yeah.
What's up, Sydney? Thank you. I've got one extra note sheet right from Bronwick, if you want to hop right in. Okay? All right, so here's what I'd like for y'all to do here. We're going to play a little game. We're going to play for Coach Jay's Halloween candy. And inside are bunches of goodness, but the majority of it is Snickers, which is my ultimate favorite, okay? All right, so here's the game. You are facing me, so it's really you versus not each other, but you're trying to face me. Your goal is to try to figure out what the answers are to all of these scenarios. So let me go through it, okay? Let's put down Max. Let's make sure we're all in. I want you to tell me whether these are discrete or continuous, based on what we were just talking about. Okay. So let me go through them, and then we'll rock and roll. The amount of free throws made. Great. No, well, you do this. You'll write them. You'll write them down here in a second, okay? A grade on a test, a shoe size, the amount of boyfriends or girlfriends you've had within your high school career, the amount of money in Coach J's account, no diss. Thank you, GAC. Coach J's height, okay? And the probability model versus the normal distribution graph. And you're just going to tell me which would go with which on that last one, okay? So amongst each other, just you could put it on your desk. You could put it, just put it somewhere. To each his own. It's fine. Hey, Sydney, if you want to join this, they can kind of help you a little bit.
Continuous like 6 to 7 stuff.
Chris, did you get one of these? What coach you get? Oh, you got those? Good job.
Yes, Papa.
Might be my favorite. I like him a lot.
The height is such a low.
This is
We're starting this game. I'm just saying things so that you can hear.
Alright, you got 2 minutes. 2 minutes.
Is that last one?
Are y'all done? This last one? You'll just tell me which goes with which. Which would go with which? So you want me to give you some real This was with freak out. Let me see. Oh, here we go.
Well, I just normally just do
Just giving you just so you can kind of picture up. We're talking about continuous graphs, like a normal distribution. Today we're talking about discrete. Okay? So think about discrete as something that's set in stone.
Oh, if anything, what is it?
So if I say how many productions do you
Yeah.
you would tell me
No, like that X and then that's a problem.
right? And so you say that because it is got me. If I said I'm trying to think
I think it's actually no.
all the scores from the competition of this game, right? If I said the possibilities of
Looks like I got it.
you don't have any score, assuming they average them together. So because you can have any score, that's continuous. We're discrete. It's set in stone. Like if I said how many people in your family, you would say how many? So that would be discrete. Okay.
Dude, what is the probability?
It's discrete. I'll give you $5.
Which one would be which? One goes with one goes with
I think the normal distribution.
Perfect. So this one is?
Okay.
Perfect. Okay, hey, let's look up here. Catherine, did you have a question? Tell me, what would discrete represent probability model, or would discrete represent normal distributions? Does that make sense?
Even if like 0.7 is fine.
Discrete amount of money.
Yeah, it's gonna be like 0.87.
Exactly. Does that make sense? Cool. All right, eyes up here. All right, eyes up here. Brianna, did you have one quick question before we get started? You're good? Okay. Can you win Coach J's candy? By the way, I've heard this joke 100 times. I did not go and get this candy. This was not my candy. Someone was like trying to diss me in the other class. Like, did you go get this candy? That's really inappropriate.
I don't get it.
Good. Thank you, Mike.
Like trigger
City just said it's not even fun size.
Oh, like the house.
They are fun size.
Oh, except for you.
Just like
All right. Hey, let's get started. Here we go. First one. Someone raise their hand and help me. Actually, together. All right, here we go. Here we go. We got to get going. Okay. Enough Coach J is. All right. As we look at this, just together, we'll answer together. Free throws made would be?
Discrete.
Discrete. Good. Grade on a test would be?
Continuous.
Continuous. Yeah, that's right. Shoe size.
That's
Discreet.
That's
Alright.
continuous.
This right here.
You
Okay.
have 7 and 7.5.
My 7.5 foot or 7.5 shoe here. It's not. No, it's not.
It's like an
As I look at this, can this be continuous? Can I go to the store and get a 9 1/4? No.
Yes, you can.
Can you?
If it's European.
Really?
Would kill Goose.
Right. Hold up.
I'm pretty sure Europeans go like.
Also, if you get custom made.
So it's custom made?
Yeah. If you get custom
Who's
made.
got custom made?
I'm not bald like that, but some people are.
Alright, here we go. As of here, I would say, I hear you, Chris. I'm going to say this is discreet, but if you put continuous, based on technicality, give it to yourself. Alright, here we go. Next one. The amount of boyfriends or girlfriends you have had. Discreet. Here's a random question. How many did I have in high school?
7.
This is
Five.
continuous too.
Why?
Because you can have half a girlfriend.
He was explaining it to Shade.
Really?
Please elaborate.
I would say I could see this one. I don't know if I see that one. Cool?
No, we're at a big argument.
Alright, here we go. Next one. The amount of money in Coach Jay's account. What's that?
No.
Girlfriends? I had one.
Yeah.
My wife.
Yay.
The girl I'm dating. True story. It's true. No, come on. What would this be?
Continuous.
Continuous. Here we go. Coach Jay's height from birth.
Continuous.
I have a question.
Yeah. All right. Here we go. Calm down, John Michael. Go.
Why wouldn't money be discreet? Because you can't have half a penny.
Well, you can't.
Oh, that is fair.
Yes, you can.
Yeah.
Use my bank
Half
here
a penny.
and sit in interest in
No,
it.
because you
That's
don't
what
have
he's
it.
I know, but
I think I
but
could
like
see that.
50 cents is half a
I could see
dollar.
that. To be honest, I need to look into that just a little bit more. I would say that I could see that what you're talking about. But if I went into usually discrete models are ones where you have like whole numbers. I'm not saying that's all the time because the shoe size is an example of one that would not be. But traditionally, it's like whole numbers. If it starts getting into the tenths and hundredths place of a penny, I would say that you're talking continuous. Does that make sense?
Yeah.
However, I could see what you're talking about. I need to go look at that just a little more. But that's a great point. Coach Jay's height would be? Continuous. Good. No jokes on that. Probability model would be?
So,
Discreet.
Discrete and?
Continuous.
Continuous. Good. Anybody get, who got all of them? Who got all of them? Cool. All right. Let's do this. Those that got all of them first, go ahead and get one. And if you got one wrong or whatever, you can still get one. Just wait for everybody else. Cool? All right. So go ahead. All right. So we're transitioning to the second one here. Okay? Actually, let's do this. While you're doing that, can I give you one quick thing? Alright, we're just doing this. Alright, right up here while you're doing this, and then we'll go to this next part, okay? Alright, eyes up here while you're getting candy, because you're gonna do this as well. I need you to put down on the left-hand side, okay, right over here, your name and what occupation you want to do, like after college. Alright, it can change. I mean, it's not set in stone. What is your occupation you want to do after college? And then tell me what your wages are per hour that you drew. Does that make sense?
What do we draw?
Your name, what you want to do with your wages over here. Cool? And once you put that down, go ahead and put your wages card on my stool. Ready? We'll go right by, look at that.
I don't understand your logic.
Yes, you do.
No, I don't. So
Did everyone get one?
next person I'm talking to, I could just be like, oh, they're half my board, but no, I can't.
I understand your logic, but
I disagree with it too.
No, it makes
I'm still trying to figure that out.
He said like if you're talking to someone, but like you don't claim them as your girlfriend, they're still half your girlfriend.
Oh, you're like Vegas, like it's
You got the girl, then you got the.
Like,
Wait, where do we put
Coach Jay.
She's 0.3.
I get $7 an hour. Coach James.
just underneath your name, just underneath, right there.
Oh wait. Oh no.
I'm a little.
Nope. So it's only $1.
He's sending us to your college.
You want to
I
be
was
an
just
astronaut?
Somebody can be one third of it.
I would be.
You want to be an astronaut?
You have 3 girls.
They did one third.
Then you would have 3 girlfriends though. You wouldn't have 1/3.
No, you have